Hello. In this session, we'll talk about the terminal, and particularly we will talk about pipes and redirects. So, what should we learn? Well, it's about the terminal again, this text-based interface where we type commands and then the computer does stuff. And today we will learn what this line does, or rather, why this line does exactly what it does. So we'll get back to this one by the end of this video. So let's recap quickly what we have learned so far. We have learned to navigate the file system, so print a working directory, change directory, list files and directories in the current directory, and we've learned the two special directory names, ... and just one dot. Dot being the parent directory, so we can go back to the parent. We've also learned how to manage files, so create directories, remove directories, empty directories that is, and touch, which updates the modified time attribute for a file or creates an empty one if it doesn't already exist. CP, which copies files, MV, which moves files, and RM, which removes files. And then we have learned about file contents, how to work with that. So we have cat, which prints the contents of a file. We have less, which prints the contents of a file. But if the contents is too long, it will page it for us, so it doesn't show us just the end. Head, which shows us the first few lines, tail, the last few lines, grep, which searches for patterns in the file and prints the lines where this pattern occurs. File, which tells us about what type of file this is, so what content we can expect in it. And then nano, which is a rudimentary text editor for the terminal, so we can edit files. So that's what we already know. So let's continue. So we're going to start with the concept of pipes. So pipes is very similar to function composition from mathematics. So hopefully we are very well aware of when we compose functions like this. Even if you are not familiar with this kind of way of writing, you should be more familiar with the other way of writing it. So we take x, put it in through the function f, get some output, which we put in as input to the g function here. So the idea is the same for pipes, but the pipe way of writing it is that we print whatever input we have. So the X might be a file, so we print the contents of it, and we send that content as input to the function f here, and then does something with it. The function f outputs a result, which is then sent as input to the function g here. And these signs are called pipes or pipelines. So we say that the content is piped from catx to f here, and it's piped from f to g. So that's how we say it. So let's have a look at some examples, and that will make things easier to grasp. So let's bring up a terminal. And there we have it. So let's see the commands here. So the first one just says echo 1. So let's see what it does. Yeah, it just echoes 1, so it prints it out. Let's see what happens if we type this one. So it outputs some numbers. Let's read what WC does. So WC prints new line, word, and byte counts for each file. So WC is short for word count. And what it prints is how many lines we have. So yeah, it was obviously one line, and it was one word. Yes, it was one word, but 4 characters. So why is it 4 characters? And that's because there is an invisible line breaking character here at the end, which makes the new line. So that's what makes a line, and that's why we have 4 characters. So we can try another similar version. This -n option tells Echo to not print a new line at the end. So if we run this one, we see that it prints 1, and then it doesn't print a new line, so our prompt ends up just behind it. So let's see how that affects the result here from WC. So if we use this one, we see that now we don't have any lines because we don't have any new line. So it doesn't count as a line. But we have one word and it has 3 letters because now we don't have the new line adding to the 4th letter. So that was those first 2 examples. Let's try the next one. So echo 1, 2, that will just print 1, 2. And let's pipe that to WC, and we see that it's still one line, it's 2 words, it's 8 characters, and that's because we have the ending new line there as well, and we count the space in between them. And let's end with the last example, which is a bit more complex. So what this one does is that it simply executes echo 1, echo 2, and echo 3, and the outputs will be like that. And we want to pipe this to the word count, which says that now we have 3 lines, and it's 3 words because it's one word per line, and it's in total 14 characters. So the reason we need the parentheses is because if we remove them and just have this, everything will look fine. So we have the semicolon to show where one command ends and the other continues. But if we only pipe this to word count, we will get this result. And that's because it's only the output of echo 3 here that is piped to word count, whereas the other 2 are executed and not piped. So if we add the parentheses, we can pipe the output of all 3 to word count, and then we get the expected behavior. So let's continue. We can do other things as well. So there are other utilities we can pipe to, for instance, sort. So let's go back and try what happens when we, instead of pipe these 3 to word count, we pipe them to sort. I suppose by the name of the command sort, it should do some sorting. So indeed, it does. So we have 1, 3, 2. So it swapped places for 2 and 3. So because that's the alphabetical order. And of course we can pipe this result to word count because this is an output, so it can be piped to the next one. And we see that, yeah, it's still 3 lines and 14 characters and 3 words. It's just they are in a different order, but the output is the same for word count. So we see the output of this one is the same as the output of this one. So let's try another example. So let's try the grep utility. So now we want to echo this. Same thing as before, but this time we want to see which lines contain the pattern E. So then we hit enter and we see that it's just 1 and 3 that contains the letter E, 2 doesn't. Now it's very little input, so we can see that, yeah, it's obviously 2, but in other cases it might be a lot more. So then we might want to use word count. And in this case, we are only interested in the number of lines. So there is an option for word count, -L, which outputs only the line count. So we see it's 2 lines that we got here. So it's 2 lines that contains the letter E. Okay, so let's continue to redirections. So redirections is related to pipes, but it's slightly different. So there are a few data streams that exists in the terminal. And these are standard output, also known as std out, or the screen, so to speak. We also have standard error, or std error, which is another stream which is also attached to the screen. So both end up printing things in the terminal. If anything comes over these streams, they end up in the terminal. And finally, we have files. We also have input streams, which is called standard input, or std in, and that one is usually attached to the keyboard, so to speak, in the terminal. And we have files, which can also be data streams. So to have an example of these different things, so we have the cat command. And in this case, we want to print the contents of an existing file. And this now standard input is ignored because cat doesn't read anything from the input. It just reads from the file and prints. And it prints to standard out, which is the terminal or the screen. So that's where the contents end up. We also have another variant of cat. That's when we don't give any arguments. Then it actually reads from standard input, which is connected to the keyboard, and it prints to the terminal or the screen. So let's have a look at these two commands as well and see what happens in the terminal. So we can see that we have a test file. So let's print that one. And there we see the contents. And if we run cat without anything, it just waits for input like this. So we can write hey, and then it will print it back at us. And then it will continue like this until we press Control D, which closes the standard input stream. So then the program exits and doesn't print anymore. So we can what we can remember from this is that standard input is connected to the keyboard and standard out is connected to the terminal or the screen. So we can see another example, and here we have an example of a redirect. So what this little symbol does, or this part of the command, so it's the same as we had before, cat and then a file name, and then we add this. So the idea is that cat prints the contents of this file, and this redirect here, it tells the terminal to, instead of connecting standard output to the terminal or the screen, it should connect it to this file out.txt, which means that anything that cat prints will go into this file instead. So we can do an experiment with this in the terminal. So let's print what's inside the test file. So it's like that. And then we redirect the output to, well, we can call it test file 2.txt. And now we see that we have a test file 2.txt. And we can print it, the contents, and we see it's exactly the same. Now, let's try the exact thing that the example says, which is to give cat a file name which doesn't exist. So we see that we don't have a test file 3, so we can try to print the contents of test file 3. And now we see that cat complains there is no such file. And we can do an experiment here by redirecting the output. So we redirect the output to out2.txt and press enter. But cat still says that there is no such file or directory, but we can see that there is a file out2, and if we check what's in it, we see that it's completely empty. And the reason this happened is because error messages are printed to standard error, whereas normal content is printed to standard output. And like I said, this redirect that we have, this one redirects standard output to this file, but standard error is still connected to the screen. So that's why we still get some text in the terminal and not only in the file. So let's continue a bit with these redirections and talk a bit more about them. So there are these different variants of redirects. So this one we already saw, which redirects output. So standard output to a file. This one does the same, but instead of replacing that file, if it already exists, it appends to it. So it continues to add at the end of the file. We'll see some example about it. And this one, it takes input. So it replaces standard input by this file. So instead of when, for instance, cat is expecting us to type on the keyboard like we saw, if we have used this one, it replaces the keyboard by the contents of that file. So if we don't want to type the same thing all over again, we can type it once in a file, and then we can use this type of redirection. So it's very useful. And this one has a particular meaning where it actually reads from the keyboard or from a script several lines, and then it sends it as input. So we'll get back to that one to when it's useful. Okay, so let's continue and look at some details. So we have the first example redirecting a standard output, and technically we have already seen this example using cat though, but we will use echo. And what echo does, we have already also seen. It simply echoes whatever we give as arguments back as output. So we can type echo contents of file.txt and redirect it to file.txt, and we see that from before here that we don't have any file called file.txt already. So let's do that. And now let's print the contents of that file, and we see that it is contents of file.txt. Now we can also check, use this append. So let's see what happens if we run this line, more contents of file.txt, and send it to file.txt. And then let's print the contents again. now we see that the contents has changed to more contents of file.txt. And that's because the standard redirect, so this one, it actually overwrites the file if it already exists. So let's try the double redirect symbol. So if we change the example to even more contents of file, and then we have this double to redirect to file, and see what happens. Now if we print it, we see that this was added at the end of the file, so that's also quite useful. So let's see another example. So let's try working with standard input and ignore that. So we saw before that if we just type cat like this and we type something, it will type it back at us like that until we press Ctrl D to close standard input. Now, if we just do this instead, so now we don't give any file name, cat will read from standard input, but we redirect standard input from this file.txt, we see that the result is that cat prints the contents of the file. So it achieves exactly the same way as if we specify the file to cat, and then cat will open the file instead of the terminals. It's one way to achieve another way to achieve the same thing. But sometimes this redirection of standard input is more useful than actually supplying a file name, because, for instance, some commands, they don't take a file name, but only read from standard input, and then you need to redirect like this. So there are circumstances where this is very necessary. So let's have a look at another example, a more complex one. So we had before echo 1, 2, 3 and piped it to word count -L to see the number of lines. So we can try that one again. So echo 1, echo 2, echo 3, close parenthesis, word count, line. So yeah, indeed, it's 3 lines as expected. Now, what we can do with the double redirection is that it takes some symbol and then it expects some input, and we can enter several lines, and then when we are done, we type this same symbol as we had up there, and then of course this symbol should be something that we don't want to input, so that's why we have an underscore and then EOF as end of file, and then we see that we get the same result. So then we send 1, 2, 3 on a line each as a standard input to word count program. Okay, so what can we say to summarize this? So we have A, pipe, B, and what the pipe does is that it connects standard output of A to standard input of B. So that's what it does. And normally, well, in this case, standard output of B is still connected to the terminal, the screen, and standard input of A is still connected to the keyboard. So that's what happens when we have a pipe like this. Now we can explain it in terms of standard in and standard out. So let's continue with an exercise. So what we've learned so far, well, we knew this since before, but now we've learned pipes and redirects. So now we want to do the same exercise as before. Which commands must you run and in which order to get the same output as we have down here? So it's exactly the same as before, except we have test files 2 here to show it's a different directory. But this time you don't use the text editor. So how would you go about doing this? Let's have a look at the possible solutions. There are a lot of solutions for this one. So the easiest one, considering we have already solved this problem before, is to create test files to directory, and then we simply copy the test file from the previous test files directory in here. So that's a bit of cheating, but it's a perfectly valid solution. Another solution, if we want to do it from scratch, is to create the test files to directory, and then we simply echo contents of test file.txt to this file. And the first time we want to make sure the file is empty if it already exists. Well, it shouldn't, but just to be clear, so here we can have 1. But in the other 2 lines, we want to append. So we append this line to the same file. So this would result in contents of test file.txt being occurring 3 times in this file, which would make grep output these 3 lines, which is exactly what we want. Another alternative is one where we can actually insert some garbage too. So we create the test files to directory, and then we print some garbage into this file, and then we echo one of these lines that we want and make sure to append it to this file. Then we can echo some more garbage into this file and append it, and then 2 more lines that we want, and then more garbage. And this will also result in the same output, because the line that we run is grep on content, and so grep will only take the lines that contain contents, which is these 3 lines that we were after. So grep will ignore these more garbage lines. So that's another alternative. Then we have yet another alternative, and that's to take the original test file that we had in the home directory and simply cat it 3 times. First one we don't need to append, the other 2 we make sure to append. That would also work. And another way is to first create the directory and then copy the test file there, and then cat and append to the resulting file. So this would also result in there being 3 such lines in this file. And yet another solution is to create the directory, go into it, and then copy the test file from the parent directory to the current directory. So this is one place where we need to use this single dot. So it's to copy the test file from the parent directory to the current directory. And then we can just echo the contents and append it to the file. And then we can either specify the file like this, or we have /test file, which would also work. So another use. So this last one makes it very explicit that it's in the current directory we expect the file to be. So that's another use of the single dot directory name. So let's move to the conclusion, and then we want to connect back to this line of commands that we saw in the beginning. So what does this series of commands do? And now you should be able to look that up using your current skills and knowledge. Okay, so let's briefly walk through what it does. So the cat command just provides the contents of Hitchhiker's Guide, if we have that file. tr-cs turns all characters other than A to Z and lowercase a to Z into a new line, meaning all words are on their own line. And tr, the next one that we have, turns all words into lowercase because it translates capitals into lowercase. And sort, of course, sorts all the lines, which by this time is just words on their own lines. And unique-c counts each word and outputs the count of each word. And then sort, this time with the option rn, sorts in reverse order, so that's what the R is for, and n for numerical values. So we don't want to sort in alphabetical order because we want 100 to be bigger than 10, which is not the case in alphabetical order. And then we have the last one, head-n10, which takes the 10 first lines of the output and ignores the rest, because those 10 lines are the 10 most frequent words in the text. So that's how it solves the problem. Now let's end with an exercise. So there are two other commands that might be useful for you, join and cut. And you should use these two commands to make a list of name and phone numbers sorted on last name. So you have two CSV files, namely these, so they are comma separated value files, so something you could export from Excel or something. And then you have, so the first name, comma, the last name, comma, email address in the first file. And then you have phone.csv, which contains the email address, comma, and then the phone number. And what you want to do is to make a phone book, so something along these lines. So you have the first name, the last name, and the phone number, and this should be sorted on the last name. So you see here that it's a different order of the names, and they should match the corresponding phone numbers. So how would you go about that? Okay, let's have a look at the solution. So one way of doing it, there are many ways to accomplish the same thing. But we know that if we read the manual pages of join and cut, we know that or join actually, we know that the records must be sorted on the joining column. So they must be in the same order. So what we need to do is to sort both names and phone number, and we need to sort them on email address because that's the joining attribute that we have. And in the first one, that's the third field, and in the phone one, it's the first field. And we need to specify that it's separated by comma, each field. And once we've done that, so we have the sorted files, so we create new files named names sorted and phone sorted. Then we can use join, and then we want to join on the first file, we want field 3, and on in the second file, field 1, and they should be separated on commas. And then we give the files, so the first one was names, and the second was phones. And now it will have joined this, but we don't want everything, like we don't want the email address. So we pipe this to cut, which we have to tell that it's separated by commas. And then we want only the fields 2, 3, and 4. And this we want to sort on the last name. So we pipe it to sort. We tell sort that it's separated by commas, and we want to sort on field 2, which is the last name. And the output of that will be the phone book that we desire. And then the last line, we can just remove these temporary files that we created with the already sorted files. And that was it for this session.